This is your stepper motor, and you need to have the driver. The stepper motor consumes more current, it takes more current. This current cannot be given by the strainer kit. It gives logic 1 and 0, and the current will be about maximum of 10 milliampere. But this motor consumes about, it draws about more than 100 milliampere. So you need to have some current amplifier in middle. That is what this amplifier does. It needs to be energized separate power supply that I have connected with this power supply. I have connected 12 volts. The same stepper motor can be available in different form factor. This is also what you are seeing as a stepper motor. The internal connection of the stepper motor seems to be like this. Basically, the stepper motor having 5 to 6 wires. So the coils are arranged something like that. So there are 4 coils. The coils are stator and the rotor is only magnet. 4 coils where all coils common terminals are connected together. It's called common. And this and all individual wires. We can name it as A0, A1, A2 and A3. It's such a way, I mean, it is similar to this figure, you can think it of. The coils are arranged like that. In middle there is a magnet. By energizing this coil and this coil, this coil, this coil, such a way that this magnet, which is a rotor, rotates towards the field of its correction. It can rotate towards repulsion and attraction forces, that you know in even schooling itself. Now what I need to do here, if I magnetize this coil, what happens? This coil is an electromagnet. When I magnetize this coil, it becomes a magnet, electromagnet. The rotor, which is the magnet part, which is focused towards this magnet. It seems to be like that. What happens when I magnetize this coil? When I don't magnetize, when I demagnetize and magnetize this, the magnet which is towards like this comes to this direction. It comes this direction and it comes towards. At last it being something like that. After that I switch it off this and I switch on this. I energize this coil. What happened? The stepper motor, which is being oriented like this, comes this way. Then I cut here and I energize this and it comes here. So similarly, when I do keep on de-energize and energize, such a way that the magnetic part, the rotor part, is consistently rotating about the magnetized and demagnetized of the coil orientation. So what we are going to do is, our purpose is to magnetize and demagnetize this coil, and we are making this rotor, a magnet rotor, to be rotated. What happened in some case, I can energize this, I can start for an hour. What happened? The rotor stays in that position for an hour, right? So I can in middle I can go this way, such a way that the motor rotates in clockwise or anti-clockwise. So any direction I can do. I think you could understand this basic things of stepper motor connections. What happened? Let me work it out. The sequence to be given to the motor: A0, A1, A2, A3. We have seen that. So coil, we have coil like this. Call this. Short this all common terminal connected to the positive volts. Now what happened? Or you can connect to ground. Nothing wrong in it. Now the common is ground. Now to energize this, you need to give logic 1 here. And energize this, you need to give logic 1 here. This is A0 and A1, A2 and A3. Let's say I start with giving some data. I energize A0. This is energized. I can take some other color. This is energized, and whereas this is not, these three are not energized. So this are all 0, 0, 0. This is a sequence I am going to give it to the motor. This sequence I can connect to the A255. I can send this sequence to the port A of A255. When I send this sequence, which is connected to the stepper motor, this coil is energized. My rotor comes in the middle. That you know it already. Then this is the first sequence. In second sequence, what I am doing is energize this, don't energize this. De-energize this. So I make this fellow to be 0. So de-energize this and I energize this. So another sequence. When I send this, what happened? The rotor comes in this. Now what is the degree of the rotor? Takes 90 degree. It takes 90 degree rotations in this case. And second in third sequence, what I'm doing, I energize this A2, remaining de-energized. So this rotor comes in this. It takes another 90 degree. Correct? So third sequence. In fourth sequence, I energize this A3, and remaining these three are de-energized. Now the rotor comes here. That's it. Again, after this, I go for the sequence 1. So I repeatedly give this sequence 1, 2, 3, 4, such way that the motor takes anti-clockwise direction. If I give the sequence in reverse, the sequence 4 I give first, second, third, and this second sequence in third, and the first sequence in last. When I give in that manner, what happens? The stepper motor takes clockwise direction. Understand? But what is the degree of freedom of this stepper motor? It is about 90 degree. Now I need to go for stepper motor needs to be run in very lower degree, but it takes about 90 degree per step. This is called 90 degree per step. How do I increase the step size? I mean, reduce the number of step size here, number of degree per step. So in that sense, you can go the same coil again. I draw it. What happened? Energize this guy and energize this also. Energize this first and this sequence, you know it already. Now what happened? The rotor comes in this. Now don't de-energize this and keep this to be energized and energize this one. What happened? Now this fellow comes in middle. It comes in middle of this and this coil. So it now the step is about 45 degree. So now what happened after this? I de-energize this and I energize only this. Now it comes in this way, and I can energize this. Still this is energized, so it comes in this middle, and I de-energize this. It comes in middle. In like that sense, I can rotate the motor and clockwise or anti-clockwise. Now the sequence will be, let's say A0, A1, A2, A3. The sequence will be first 0 0 0 1 1 and 0 1 1 0 and 1 1 0, then 1 0 0 1. So at a time 2 coils are energized. I think you could understand this, right? This is 1 1 0, this is 1 0 0. What is this? This is 3, this is 6, and this is of course C, and this is 9. I can give this sequence in hexadecimal. In hexadecimal, it is equal to this number. I can give this data in C, to port A, such a way that the motor takes step by step rotations. Now what happened? I can repeat the same sequence here. So 1 1 0 0 and 0 1 1 0, 1 1 0 0 and 1 0 0 1. So if you have this sequence, it is about 33H. And next sequence is 66H, and this is CCH, and this is 99H. Now what I can do, 33H or 66H or any one of the sequence I can take. I can keep on shifting either left or right, such a way that I can get other sequence. What happened? 33, if we shift right, I will get this sequence, right? 99H. 33, if you shift left, what happened? I will be getting 66H. So any data if I shift, I will be bounding to only those 4 sequences. So in our program, we have taken 66H to rotate in all axes. I think you could understand this.